Hello, so let's look at what standard temperature and pressure, STP, means, and we'll just look at a short example of how to apply that. So we're asked, determine the mass of gas present in 2 liter of hydrogen at standard temperature and pressure. So it tells us we have 2 liter of hydrogen gas. We want to determine, well, first the number of moles, and then the mass of hydrogen present, if there's 2 liter of it at standard temperature and pressure. Right, so the first question is, what does STP mean? Well, STP stands for standard and then temperature, pressure. So it says something about the temperature. So the temperature is 0 degrees Celsius, which is also 273.15 Kelvin. The pressure is 1 atmosphere, or 760 millimeter tall, millimeter mercury, not millimeter tall, but also 760 tall. Is what it's known for. And then the one thing that's now not linked in that, the third thing, so you can actually list them as number one, number two, and then the third thing that you know is the number of mole, or something about the mole. So actually is that there exists a molar volume. So it's that 1 mole of, why can't I write the right thing? 1 mole of gas, ideal gas, that's it, but 1 mole of ideal gas has a volume of 22.414 liter. And that is actually known as the molar volume. 22.4 mole per liter is the molar volume of an ideal gas at STP. So 1 mole of gas will have a volume of 22.4 14 liter. So those are the three things that we know at standard temperature and pressure. Right. So how can we use that information with the volume that we were given to calculate the amount of gas? Well, we want a way to calculate N. So what is the N of hydrogen? That is our question. Now, we know that this is a ratio. All of these things are ratios, but the important ratio is this one here, this last one. It tells us that 1 mole of gas will be present in 22.414 liter. So then our question is, how many moles, so X mole of gas, will be present in 2.00 liter? That will give us the number of mole. And then from the number of mole, we can get the mass of hydrogen. All right, so that's essentially how we go about this. So from this we can get that the number of moles of hydrogen that we have present here is going to be equal to 2.00 liter hydrogen multiplied by 1 mole hydrogen in 22.414 liter. Okay, and I mean, you're going to get some value here. So what is it? It's like 11, 1 over 11. So it's like 0.09 something, 0.089 or something like that. Okay, so you're going to get some value here. Not really that important. And then how do we calculate the mass? The mass of hydrogen is then, of course, equal to the number of mole multiplied by the molar mass. So the number of mole of hydrogen multiplied by the molar mass of hydrogen. So in this case, we plug in all those values because it's 2.00 liter hydrogen gas multiplied by 1 mole hydrogen is in 22.414 liter. then multiplied by the molar mass, which is that there is 2.016 gram hydrogen per mole hydrogen gas. So you will get a value of 0.180 gram H2. Okay. So the things that I wanted to introduce in this question was, what does STP mean? Firstly, so the temperature is 0 degrees Celsius, pressure is 1 atmosphere, and we know that 1 mole of gas will have a volume of 22.414 liter. So hence, we can use that in some way to get the number of moles of a gas, and then from that, the mass. Okay, thank you for watching.